Hello children, welcome back to the channel. Today we will be continuing our discussion on Newton's second law of motion from the last video. If you haven't seen the previous video, then the link will be given in the description below. So what we have found is that the second law states that the rate of change of momentum is directly proportional to the applied unbalanced external force, and also this change of momentum will take place in the direction of the applied force. Now we already know that momentum P is given by m into v, mass multiplied by the velocity. So we can say that dp by dv, so dt, rate of change of momentum, will be equal to d dt of mv. But m is a constant, so we can take the constant outside the derivative sign and we can say m into d v by dt. But we know that dv by dt, rate of change of velocity, is acceleration, so we can say m into a. Therefore, Newton's second law of motion, using equation 1 here, simply states that the acceleration produced in a body of mass m is directly proportional to the unbalanced applied force, external force. Or we can say that force is equal to some constant of proportionality k into mass into acceleration. Clearly, it's a vector equation. Force is a vector, acceleration is a vector, so the relationship between force and acceleration is a vector relationship. This we need to keep in mind. So if I take modulus of both sides, we get F magnitude of the force must be equal to constant times mass into acceleration. Okay. Now comes the important part, that force is some constant into mass into acceleration. Now this constant of proportionality k, what we want to do is that we want to do away with that, so that the relationship becomes a little bit simpler. So how to do that? To do that, what we do is that we choose the units of force, mass and acceleration in this way such that if F equals to 1, that is 1 unit of force, and if this force of 1 unit is applied to a mass of 1 unit, then the acceleration produced in the mass is equal to 1 unit. What it means is that we choose the unit of force, mass and acceleration such that this relationship is true, that 1 unit of force applied to a mass of 1 unit will produce a unit acceleration in the body. If it is so, and if substitute these values in this equation, say equation 2, then we have 1 equal to k multiplied by 1 multiplied by 1, that is k, the constant of proportionality, becomes equal to 1. So we are able to eliminate or remove or set this constant of proportionality equal to 1, so that equation 2 is essentially going to be reduced to F equal to m into a. This is the famous equation of Newton, F equals to ma. Now this equation is generally, many times what students do is that whenever they are asked about Newton's second law of motion, they say that F is equal to ma. However, this is not the statement of mathematical statement of Newton's second law of motion. The mathematical statement is actually F is proportional to dp by dt, and F is equal to ma is a derivation from that particular equation. So please bear this in mind. second law of motion is different, and this F is equal to ma is a relationship that is derived from that second law of motion. Do not get confused in this. Now, if we say units of force, so if we have a mass, see, we know the standard units, the SI units. So unit for mass is kg. So if m equals to 1 kg, unit for acceleration is meter per second square. A is equal to 1 meter per second square. Then F will be equal to 1 kg meter per second square. This term kg meter per second square is given the name Newton in the honor of Sir Isaac Newton, and it's also abbreviated as N. If we consider the CGS units, this is SI, CGS. M is 1 gram. Acceleration will be given by 1 centimeter per second square. Therefore, force will be equal to 1 gram centimeter per second square. This is known as dyne, or abbreviated as DYN, dyne. Fine. Now, if I take this equation, 1 Newton of force equal to 1 kg meter per second square, which is equal to 1000 gram into 100 centimeter, because 1 kg is 100 grams and 1 meter is 100 centimeter per second square, or we have 10 to the power 5, 3 plus 2, 5 gram centimeter per second square. That is to say 1 Newton equal to 10 to the power 5 dyne. Clear? Now, from this equation, if I take dimension on both sides, F equal to ma, what is the dimension of force? Clearly, this is equal to dimension of mass, that is m, dimension of acceleration, that is L, T inverse 2. So, dimension of force is m, m1, L1, T inverse 2. Clear? Okay. In addition to these two units, there is another unit of force that is quite commonly used, is the kg weight. Or kg force. What is kg weight? Kg weight is the force required to produce an acceleration equal to acceleration due to gravity for A to be equal to G, which is 9.8 meter per second square. We know that, right? So, kg weight, 1 kg weight is the force required to produce an acceleration of 9.8 meter per second or meter per second square in a body of 1 kg. So this is 1 kg into 9.8 meter per second square, which is equal to 9.8 kg meter per second square, but kg meter per second square is Newton, so 9.8 Newton. However, please remember, this unit is not a constant unit. Why? Because we will find in the next chapter on gravitation that acceleration due to gravity is not a constant. It will vary from equator to pole. It will vary depending on the altitude of the place, or it will vary depending on the depth of the place from the Earth's surface. And also acceleration due to gravity on Earth is different than the acceleration due to gravity on Moon or acceleration due to gravity on, say, Uranus, or say Neptune, or say Venus. So ultimately what is happening is that kg weight, the value of kg weight will keep on changing based on the acceleration due to gravity, and that's why it's not a constant. Its value is never taken to be a constant. However, on Earth's surface, on an average, it is taken to be 9.8 Newton. Right? Okay. Now let's consider the force. We have already seen that force is a vector. So we can always write force in terms of its rectangular components. Let's say F is equal to Fx I cap plus Fy j cap plus Fj k cap. Also, since momentum is a vector, we can write momentum P equals to Px I cap plus Py j cap plus Pj k cap. And acceleration A, being a vector, is Ax I cap plus Ay j cap plus Aj k cap. Now what we have found is that F is equal to dP by dt or equal to m into A, because dP by dt is ma, and we have found F equals to ma in vector notation as well. F equals to ma. If it is so, then we can say that Fx I cap plus Fy j cap plus Fz k cap must be equal to d dt of Px I cap plus Py j cap plus Pz k cap is equal to m multiplied by Ax I cap plus Ay j cap plus Az k cap. Isn't this equation? So, for these to be true, we know that since these are vectors, so their x components, the y components, and the z components must be equal to each other, which means that we conclude that Fx must be equal to dpx by dt is equal to max. Fine. Similarly, Fy equal to dpy by dt plus equal to may, and Fj equals to dpj by dt, which is equal to maj. Right. Now, from this equation, we can conclude or make certain inferences about the Newton's second law of motion, or from the second law of motion. Number one is, since F is equal to ma, vector F equals to vector ma, so Newton's second law of motion is actually a vector law. Number two, when F equals to 0, this relationship means that even if there is a mass there, but the acceleration has to be 0. A must be equal to 0. Both are 0 vectors, that is. Which means if there is no applied force, there will be no acceleration. If there is no acceleration, then the state of motion of the object, that is, if the body was at rest, it will remain at rest, and if the body was moving with certain speed along a certain direction, it will keep on doing so. Which means this will imply the first law. Which means if there is no external force applied, the second law of motion reduces to the first law of motion. Number 3 is that applicable to rigid bodies. See, what do we mean by rigid body? By rigid body, we mean that the shape or size of the object or the body is not going to change under the influence of the applied force. Why it is important? Because in the previous video on introduction to laws of motion, we said that force can either change the state of motion of an object, or also it can change the size and shape of the object. We have taken the example of an elastic or a rubber band to prove or to explain that. Now, if the body is not rigid, then the applied force, some of the force is going to change the size or change the shape of the object, which means the entire applied force is not going to produce the acceleration. The external force is not going to convert it into motion of the object, and as a result, this equation will not hold, or Newton's law is applicable only to rigid bodies where the size and shape of the object is not going to change under the application of the force. Number 4, it's a local law. What it means is that the applied force produces acceleration at the point where it is being applied. That is, if I take a ball and apply a force on this, the ball is going to get accelerated. However, anything else there, say if there is no friction, that is, the ball was resting on a block, the block is not going to be affected by this applied force, which means it will produce the change of motion on the point of application, and also it will produce or keep on producing, or it will keep the change of motion happening only till it is being applied. If the force is removed, no further change in motion will happen, which means if you have a say ball at rest, you apply a force for certain time, then it will keep on accelerating. The moment you release the force, the acceleration will stop and the ball will continue to move with the velocity it has gathered over the period of time when the force was being applied to it. Right? Now, coming back to the magnitude of this equation, F equal to ma factor equation. Magnitude of force is equal to mass times the acceleration, magnitude of the acceleration. Or we can simply say that m is equal to F by A. Just rearranging. Now, if A equals to 1, that is, if the acceleration produced is 1 unit, then m becomes equal to F. Right? So, we can say that mass can be measured with the help of force if the applied force on an object produces certain acceleration in it, a unit acceleration in it, then the magnitude of the force will be equal to the magnitude of the mass, which means that mass is equal in magnitude only, to the force required to produce unit acceleration in the body. So mass is a measure of force required to produce unit acceleration. Force is a measure of mass required to produce unit acceleration in the body. So, in other words, mass itself is a measure of the amount of resistance that the object produces or offers to the applied force. In other words, mass is, see, the resistance to the applied force is known as inertia, because of inertia a body doesn't move even if it's when it's there is no force being applied on it, and if because of the inertia higher, if the inertia is higher, you need more force to produce an acceleration. So from this equation, we can also say that force is proportional to m. So larger the mass, more force will be required to produce the desired acceleration. In this case, 1 or unit acceleration. So what it means is that mass gives us a measure of inertia, the resistance to change in state of motion, and mass thus measured in terms of applied force by the produced acceleration is known as the inertial mass. Why inertial mass? Because it gives us a measure of the inertia. We have already said in the previous video that mass is a measure of inertia, where we were discussing law of inertia. If you haven't seen that video, please refer to that. The link is given in the description below. Now, there is another way of measuring mass which we will find in the chapter on gravitation, and then we will define another type of mass which is known as gravitational mass. That for the video on gravity or gravitation. Okay, now let's consider a few numericals from second law of motion. In the first one that we have here, we are given that we have a vehicle of mass 1000 kg moving with an initial velocity of 10 meter per second in one particular direction. It is at that, when it was moving with 10 meter per second, a force P of 1000 Newton was applied to it in the same direction as the motion. The force of friction between the vehicle and the road is given to be 500 Newton, which will always act in the direction opposite to the direction of motion. We are supposed to find the velocity when time is 10 seconds. What is going to be velocity when the object is under the applied force for 10 seconds? Okay, so to do that, first of all, we need to find the applied unbalanced external force, the total or the net force acting in the direction of the motion, which is clear is that P must be equal to P minus F. P is acting towards right, friction is acting towards left, so the net force will be this minus that. Right? So we have 500 Newton. Now what we do with the force? When we apply a force on an object, it will accelerate. So what is going to be the acceleration that is produced? F is equal to ma will give us A equal to F by m. Right? Which is equal to, force is 500 Newton and mass was given to be 1000 kg, which will give 0.5 meter per second or meter per second square. Right? So acceleration is given, the time is given 10 seconds. So V is equal to U plus AT. Equation of kinematic is going to give us the required velocity. Substituting the value of U to be 10 meter per second, acceleration 0.5 meter per second square, and time of 10 seconds will give us 10 plus 5 equals to 15 meter per second, and this is going to be our answer to the problem. Okay, now for the second problem, you are given that an object has a mass m and its position is given by this equation as x is equal to 8 t to the power 4 minus b t cube plus ct. You are supposed to find the force at time t. So how are we going to do that? First and foremost, we know that F equals m into A, or we can say that A is given by dV by dt, or we can say m d dt, V is given by dx by dt, or we can say that m d square x by dt square. So to find the force, we have to differentiate this position with respect to time twice and then multiply it by the mass. So now this is first part. Now what we need to do, we need to find dx by d square x by dt square. To do that, let's say now x equal to a t to the power 4 minus b t cube plus c t. Therefore, dx by dt must be equal to a t to the power 4 d t to the power 4 by dt minus b d dt of t cube plus c d dt of t, which is 4 a will be here and t cube, right? 4 t cube d to the power 4, differentiation of d to the power 4 with respect to t is given by this 4 t cube minus b into 3 t square plus c into 1, which means this is equal to 4a t cube minus 3b t square plus c. Therefore, d square x by dt square, which is differentiating dx by dt with respect to time, is equal to 4a will come out d dt of t cube minus 3b d dt of t square plus differentiation of the constant with respect to time. The constant is not going to change with respect to time, so it will be 0. So this becomes equal to, I'm just sorting the steps, 3, 4, 12 a t square minus 3 into 2, 6 b t. Right? Thus, therefore, equation number 1 will give us, this equation will give us f equal to m into 12a t square minus 6b t, or we can say 6 m into t, m into 2t minus b into t, whichever you have parents. This is the answer. Okay, you have been given that an object of mass m1 when acted upon by a force of 5 Newton produces an acceleration of 8 meter per second square. Another block of mass m2, when the same force 5 Newton acts on it, an acceleration of 24 meter per second square is produced. If you combine these two masses, that is, you take a mass of m1 plus m2 and apply the same force 5 Newton, what is going to be the acceleration? So our problem is to find the acceleration of this mass m1 plus m2. M equal to m1 plus m2. Now clearly f is equal to ma, or a equals to f by m. So the required acceleration can be found if we can find m, that is m1 plus m2, because f is already given to be 5 Newton. So how to find m1 and m2? To do that, let's first take help of the first equation. From this, applying f is equal to ma for this particular mass m1, we get f, that is 5 Newton, must be equal to m1 into acceleration, that is 8. And this will give us m1 to be equal to 5 by 8. Let's call this 1. Similarly, the second equation, from the second case, we get m2 equals to 5 by 24, 2. Therefore, 1 plus 2 will give us m1 plus m2 to be equal to 5 into 1 by 8 plus 1 by 24. that is m required in this equation, say A, is equal to 5 into 24, this is 3 plus 1, which is equal to 20 by 24. So 4, 5 and 4, 6, this is 5 by 6 kg. Therefore, equation A will now give us acceleration equals to F, that is 5 Newton by 5 by 6 kg, or equals to 6 meter per second square. This is our desired result.